Hello, Mrs. Cates here. Today, I want us to practice counting fractions. So we are going to do a count around. We are going to start on 1/8. We are going to stop when we get to 32 eighths. And as we're counting, I want you to really pay attention to how you're naming that number, how you're saying that number. And then when we finish, we're going to look at some of our fractions and think about what that number means. So as we count, I want to count together. So you say it just as loud as Mrs. Kate says it, okay? Let's go ahead and get started. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8, 12/8, 13/8, 14/8, 15/8, 16/8, 17/8, 18/8, 19/8, 20/8, 21/8, 22/8, 23/8, 24/8, 25/8, 26/8, 27/8, 28/8, 29/8, 30/8, 31/8, 32/8. Okay, now that we have counted from our start of 1/8 to our last number of 32/8, I want you to take a moment to think about where are our whole numbers at? Where are our whole numbers at? And once you think about that, I want you to think about how can you prove that? How can you prove that that number is a whole number? So we are going to come over here. Maybe we're not. Okay. So let's think about that. I'm guessing that a lot of you were very quick to think about 8/8 as being a whole number. How could we prove it? Could we draw a picture? Let's look at that. So I think I'm going to draw a rectangle shape in my very best drawing and partition it into halves and then partition it 1, 2, 3 more times, and I should have 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Now, of course, we're going to pretend like all of those parts are equal. Drawing on the screen is not as easy as it could be. So let's think about 8/8. If I had 8 pieces, 8 equal pieces, and 8 pieces to make my whole, do I have a whole number? Yes, I have the whole number of 1. Okay, where else do I see a whole number? Yeah, you're right. 16/8. What whole number does 16/8 represent? Could we draw a picture? Pause the video for a moment and draw a picture of what that would look like. Okay. So 16/8 is the same number as 2. Do we have any other whole numbers represented in our counting today? Oh, yes. I think you're starting to notice a pattern. So, could we represent 24/8 with a picture? If we were to draw 24/8, and you know what? I think I'm going to draw it right up here. So here's going to be my 24/8. And of course, we're going to pretend that my holes are all the same size. Oh man, Miss Cates needs to practice this, doesn't she? Whew. I'm going to partition each of them into half. And then each of them into half again. Oh man, I think I'm getting worse instead of better. That's okay. We are going to make this work. Okay, do I have 24/8? How many pieces make up my whole here? I have 8 pieces plus another 8 1/8 plus another 8 1/8. So I have 8 eighths, 16 eighths, 24 eighths. And how many holes does that make? 1 hole, 2 holes, 3 holes. So 24/8 is the same as the number 3. And then I bet you realized down our column here, our last column, we are representing whole numbers. So if we have 8/8, which is equivalent to 1, we have 16/8, which is equivalent to 2. We have 24/8 equivalent to 3. What is 32/8 equivalent to? Yes, you're right. It's equivalent to 4. So let's change colors here for a second. And let's look at something different. Could we represent a different number with a picture? I want you to think about this number right here. How could I draw a picture to represent 12/8? Go ahead and pause the video now and do that on your paper. Draw a picture to represent 12/8. So compare your picture to my picture. Instead of drawing a rectangle this time, I'm going to draw a circle. Am I just going to need one circle to draw 12/8? Nope, you're right. I'm going to need 2 circles to make 12/8. And of course, we're pretending that Mrs. Cates drew 2 equal-sized circles. Trickier than it looks, isn't it? We're working on being precise, though. So each of my whole circles, how many pieces do I need in each circle? I'm going to need 8, aren't I? So kind of like we did with the rectangles earlier, I'm going to start by partitioning my circles into halves, and then partitioning my halves into fourths, and then partitioning my fourths into eighths. Oh, let me see if I can do that again. Eighths. Right through that middle point. There we go, that center point. So 12/8. If I know that 8/8 represents 1, then I know that this whole circle here makes 1. That is 8/8. But do I only need 8/8? I'm going to go ahead and I'm going to represent that I've colored, or I have all of that. 8/8 right there. So that is 8/8. So how many more 8s do I need in my second circle? 8/8 and 4/8 would give me my 12/8. So let's go ahead and let's just count. So here's 1/8. So 8/8, 9/8, 10/8, 11/8, and 12/8. How much of my circle did I just color in now? How much of that second circle did I color? I colored 1/8, 2/8, 3/8, 4/8. So this part right here represents 4/8, which is the same as what? What is that the same as? How much of that second circle did I color in? Yes, you're right. I colored in half of my second circle. So if this is 4/8, which we are saying is the same as 1/2 of my circle. Those two numbers are equivalent. 4/8 is the same as 1/2 of my circle. So I represented 12/8 by drawing 8/8 plus 4/8, and that made my total of 12/8. I want you to do another one of these. Let's see. I would love to see how you might represent 6/8. Go ahead on your paper and represent 6/8. As you're doing that, think about maybe another name for 6/8. What else could we call that number? Okay, so I'm going to leave you right there to continue thinking about how you could name 6/8 besides just naming it 6/8. Of course, you are welcome to pick another fraction, another number on this count, and to do the same thing with it. You may draw a picture of that fraction. You may think about other ways to name that fraction. And then if you're feeling very adventurous, then you could also count by 6. So what if I started my counting on 1/6 and I counted until I got to 36? What would that look and sound like? Okay. Great job working with me today, guys. Can't wait to see you back at school. Talk to you later. Bye.